So in this series, the first we're going to look at is density. Now, density is the mass per unit volume of a substance, meaning mass over volume. Now, in this series, one of the things that you are going to be very conversant with is how to use the units of these quantities. I'm going to take time to break them down to you. So mass over volume. The unit of mass is kilogram, and then the unit of volume here will be meter cube. So after solving your question on density, you should have kilogram per meter cube as your unit, or gram per centimeter cube. I'm going to start from the origin. When I say the origin, I mean where this meter cube and centimeter cube are coming from. So we'll solve one or two questions on area and then volume, and then we start with the actual thing. This is just to help you to understand whatever you are going to do deeply. So the first question says, calculate the area of a rectangle with a length of 12 centimeters and a width of 5 centimeters. So area of a rectangle, length times the breadth, or length times width. Now, the length is 12 centimeters, and the width is 5 centimeters. Now, 12 times 5 is 60. Now, centimeter times centimeter is centimeter squared. So anytime you see centimeter squared or centimeter cube, know where it's coming from. So there's also a question on volume. Now, a cuboid measures 4 centimeters by 6 centimeters by 8 centimeters. Find its volume. So for volume of a cuboid, is the length times the width times the height. So our length is 4 multiplied by our width is 6 multiplied by our height is 8. So 4 times 6 is 24. 24 times 8, it's 192 centimeter cube, because you're multiplying thrice. Now, what if the units were in meters? So it means that it would have been 192 meter cube. Now take note, one of the mistakes some students make is they work with different units. Let's just assume that this question we had, let's say 4 meters. Let's say this question, let's say we had 4 meters multiplied by 6 centimeters multiplied by 8 centimeters. What would you have done? Now you're not supposed to work with different units. So what you're supposed to do, you're supposed to convert. Now in order to convert, there's this big system you are supposed to know. 1000 millimeters equals 100 centimeters equals 10 decimeters equals 1 meter. Now with this, we are good to go to do any conversion in most science topics if it has to do with length. Yes, so it's either, for this question, it's either you convert all the units to meters and work with them, or convert all the units to centimeters and work with them. Since centimeter is here and centimeter is here, I would love to convert this one to centimeters. So how do I do the conversion? Now this is 4 meters. 4 meters, I need to convert to centimeters. Now, looking at them, you have 1 meter here, 100 centimeters here. So I can equate them. So assuming you were converting from decimeter to millimeter, just pick this and then that, and then equate them. So from this, I know that 100 centimeters equals 1 meter. Now why am I doing this? I'm doing this because you will need the understanding of this for this whole series, because the units or the calculation topics in physics, it's such that it's cumulative. When I say it's cumulative, you need to understand one before you move to the next one. So I would encourage that you watch the whole playlist. So we want to convert 4 meters. So 4 meters. So what you do is meter under meter equals, so if 100 centimeters equals 1 meter, what will be equal to 4 meters? Now let's think through it. Let's think through it. Are we expecting more or less? If 100 centimeters give us 1 meter, we're expecting something more. So if more, less divide. This is the less. So we're going to have 4 over 1 times 100. So we're going to have 400 centimeters. We are going to be using the 400 instead of the 4 meters. Now we are ready. So we are about to start with the density. Alright. So we already stated the formula for density. We said density. This is a symbol for density. Equals mass over volume. Now, the mass was given to you in grams. So 500 grams over the volume, 250 centimeter cube. Now, gram always goes with centimeter cube. Kilogram always goes with meter cube. So let's just assume that in the question, this was, let's say, in kilogram, and this was in centimeter cube. What you are supposed to do is you are supposed to convert it to grams. You are supposed to convert kilogram to grams before you can work with the centimeter cube. Or you can also choose to maintain the kilogram here and convert this one here to meter cube. Alright. So you see that it's not just a one-way thing. So 500 divided by 250. We have 2 grams per centimeter cube. So that's our final answer. Now try this one. You can pause the video and then try this. So a liquid of mass 2.5 kilogram occupies a volume of 0.02 meter cube. Find its density. How do you find the density? Same approach. Density equals mass over volume equals 2.5 kilogram. Remember, as I said, since this is in kilogram, this is in meter cube, there's no need to do any conversion. So 0.002 meter cube. Now, when you do your division very well, 2.5 divided by 0.002, we have 1250 kilogram per meter cube. An object floats in water with 80% of its volume submerged. If water has a density of 1000 kilogram per meter cube, calculate the object's density. Now, in order to be able to solve this, we need to use the principle of buoyancy. Now, what does the principle say? The weight of the displaced water is equal to the weight of the floating object. So let's say I have water and I have an object in the water. So the weight of this object will be equal to the amount of water which will be displaced. So the short dashes is the level at which the water will get to, but that is actually not the level or the height the water is supposed to get to. It's as a result of the floating object. Now it means that weight of the displaced water equals weight of the object. Now the object density relates to the density of water. So fraction of submerged equals density of object over density of water. Take note of this formula. In the next series, we'll come to it. Now, it says what? The object floats in water with 80% of its volume submerged. So 80% of the object is submerged. So we have that density of water equals 1000 kilogram per meter cube. We have that down. So this is a fraction of submerged. How do we know? 80% is 80 over 100. Now 80 over 100 equals, divided by 100, we are going to have 0.8 equals, so what you want is the density of object. We don't know that. I know the density of water is what? 1000. So density of water is 1000. So in order to get, we multiply this by that. We are going to have density of object equals 0.8 times 1000 is 800 kilogram per meter cube. I know you are not used to this formula, but stick to it and you need it elsewhere. You can try your hands on this one. Just pause the video and try. So the question says calculate the mass of an object with a density of 8000 kilogram per meter cube and its volume 0.01 meter cube. Now we know density of an object equals mass over volume. Now from here, one thing I'll always advise you to do is write out the information every time. So density is what? 8000 kilogram per meter cube. The volume is 0.01 meter cube. Now, writing the information out helps you to summarize everything. You don't need to read through again. Now, it's either you make the mass the subject. So, actually don't make anything the subject. I just fix them in and then fix the numbers in first before I make anything the subject. So, your density is 8000 equals, the mass is what we don't know, over the volume 0.01. So your mass will be equal to 8000 times 0.01. So the mass of the object is going to be 80. So is it 80 grams or 80 kilograms? 80 kilograms. Why? Because there's kilogram here. And if you even do it very well, you realize your kilogram per meter cube will be here. And once your meter cube is here, you will have your meter cube here. You would have your meter cube here. Meter cube will cancel meter cube. So what you have left is your kilogram. So it's your kilogram. The continuation of this series. And in this part, we are going to look at relative density. Now, relative density refers to the ratio of the density of a substance to the density of water. There are different formulas used to calculate relative density. So let's look at some of them. So relative density equals density of substance over density of water. Relative density could also be mass of substance over mass of water. It could also be volume of substance over volume of water. We could also have the weight of a substance over the weight of water. So it's always comparing a ratio of a quantity of a substance or an object to that of water. So let's start solving the questions. Now there's something you need to know about relative density. Now relative density of water is either 1000 kilogram per meter cube or 1 gram per centimeter cube. So if the question has to do with kilogram per meter cube, you go with this. If it has to do with gram per centimeter cube, you go with that. Okay, so looking at this question, an object has a density of 2500 kilogram per meter cube. What is its relative density? Now you can try it. You can pause the video, try it. Alright, so relative density equals density of of objects in the case of this question is an object. Density of object over density of water. So the density of the object is 2500 over density of water. Now we are not going to use the 1 gram because I mentioned already at the beginning of this series that you are always going to be careful of the units that are involved in solving. So it's kilogram per meter cube. So kilogram per meter cube, 1000. So when you punch this on a calculator, you're going to have 2.5. Now take note, relative density does not have a unit because now the kilogram per meter cube for this, the kilogram per meter cube for this will cancel out. So take note, relative density does not have units. So that's it for this question. Now in the next one, a substance of mass 20 grams displaces 15 cm cube of water. Find its relative density. The volume of water displaced equal to the mass of water displaced. Relative density equals, over here we are dealing with mass. So the mass of the substance, mass of substance over mass of water. So mass of substance is 20 grams. So this 15 cm cube will actually be 15 grams. So when we cancel out, you are going to have 1.33. That's the answer to this question. Now to the next one. A block floats in a liquid with relative density of 0.8. If the block's relative density is 0.5, what percentage of its volume is submerged? For a floating object, the volume of submerged over total volume will be equal to relative density of the block over relative density of liquid. Now, the block has a relative density of 0.5 over the relative density of the liquid is what? 0.8. So you realize that with relative density, you are always dealing with the ratio of the substance to the liquid. Over here is in water. So the formula for relative density could also be relative density of substance or relative density of water. Over here it's a liquid. We are going to have 0.625. Now we ask what is the percentage. Now to get percentage, all you have to do is to multiply this by 100. We are going to have 62.5%. So 62.5% of the block's volume is submerged. So I guess you can try this. You can pause the video and try this question. So if the mass of an object is 30 grams, it displaces 20 grams of water. Calculate its relative density. So with this, relative density equals mass of object over mass of water. So the mass of the object is 30. The mass of the object is 30 over mass of water is 20. So work it out, you're going to have 1.5. Then the last question. A liquid has a density of 850 kg per meter cube. Calculate its relative density compared to water. Now with this, we have kilogram per meter cube, and I already mentioned that relative density of water is 1000 kilogram per meter cube. Sometimes it will not be given to you in a question, so take note. So relative density equals, always say the formula, density of liquid over density of water. So 850 is for the liquid, then 1000 is for the water. We're going to have 0.85. Now in this series, we are looking at velocity. Now velocity refers to change in displacement with time. So mathematically, velocity will be represented as velocity equals displacement over time. Now, some people confuse speed with velocity, but even though they are similar, they are not the same. Velocity is a vector quantity. Speed is a scalar quantity. So speed is distance on time. Now displacement is a vector quantity. Distance is a scalar quantity. Now, how do you get the unit? The unit for displacement, change in distance, is meters, or it could be centimeters and what have you. Now, the standard unit for time is seconds. So it works the same for the speed as well. So you're most likely to see meters per second. So that's what you're going to use. Now, if you follow my series, you realize that when you're using standard units, you're not supposed to use centimeter per second. So if a question is given to you and the distance is in centimeters, you are supposed to convert it to meters before you can work. For time, it is seconds. So we either have kilometer per hour or meter per second, as you can see here. So we dive in right away. So with this question, a car travels 150 meters in 15 seconds. Calculate its velocity. So this is very basic and simple to follow. So first, your distance is 150 meters. Then your time is 15 seconds. So your velocity equals distance over time. So your distance is 150 meters over your time, 15 seconds. So doing your calculation, 150 divided by 15, you're going to have 10 meters per second. That's your answer. So a train travels 90 kilometers in 2 hours. Find its velocity in meter per second. So for this question, you realize that the distance was given to you in kilometers and your time was given to you in 2 hours. Now there are two ways to go about this. It's either you convert this to meters and this to seconds and work, or you work it out. Afterwards, you convert your answer in kilometers per hour to meter per second. So we'll look at both approaches. So the first approach, you know that your velocity equals distance over time. So your distance is 90 kilometers over the time 2 hours. So what is you're going to have 45 kilometers per hour. Now, with this, what would you have to do? You have to convert kilometer per hour to meter per second. Now, 45 kilometer per hour. 45 kilometer per hour means 45 times 1 kilometer over 1 hour. That's what it means. Now, ask yourself, you want to convert this to meter per second. So we have to change this to meters, change this to seconds. How do you go about it? So 1 kilometer equals how many meters? So 45 times 1 kilometer. 1 kilometer is 1000 meters. Take note, 1000 meters equals 1 kilometer over 1 hour equals 3600 seconds. So 45 times 1000 is 45,000 over 3600. So 45,000 divided by 3,600. You have 12.5 meter per second. So I mentioned another approach where you convert this to meters, this to seconds, and work it. So we know that our answer is what? 12.5. So let's expect 12.5. 12.5. So converting 90 kilometers to meters. 1000 meters equals 1 kilometer. So 90 kilometers will be 90 times 1000. We are going to have 90,000 meters. Then 2 hours. 1 hour equals 3,600 seconds. So 2 times 3,600 will give us 7,200 seconds. So this is our distance, this is our time. So velocity equals 90,000 meters over 7,200. So 90,000 divided by 7,200. Still have the same 12.5. So that is it. The ball rolls at a velocity of 10 meters per second for 25 seconds. Calculate the distance it travels. So you've been given the velocity. Now I always say write the information out. So you always don't think that you're always finding velocity, because this question is asking you to calculate the distance. You know that velocity is distance or displacement over time. So your velocity is 10. So write your 10 here equals your distance d over 25. So your distance over here is going to be, so you are going to cross multiply. You are going to have d equals 250 meters. Now always take note of the units so you don't mess things up. A runner increases their velocity from 2 meters per second to 6 meters per second in 5 seconds. Calculate the average velocity now. So the formula for average velocity is, so let me represent it with AV equals initial velocity plus final velocity all over 2. So the initial velocity is 2 meters per second and the final velocity is 6 meters per second over 2. So 2 plus 6 is 8 meters per second over 2. So we have 4 meters per second. So this is the formula for finding average velocity. Kindly take note. Pause the video and then try this question. Kindly pause it and try it. So a cyclist covers 20 kilometers in 40 minutes. Convert their velocity to meter per second. So if you are following, you should know that converting this to meters, converting this to seconds. So your distance, 20 kilometers, will equal to, we know that to convert kilometers to meters multiplied by 1000, you're going to have 20,000 meters. Then 40 minutes, your time, 40 minutes. Now 40 minutes to seconds, 60 seconds. 60 seconds equals 1 minute. 50 seconds equals 1 minute. 40 minutes. So in order to be able to do this, what you do is multiply 40 by 60. So 40 times 60, you're going to have 2,400 seconds. So your formula Velocity equals distance over time. So your distance is what? 20,000 over your time, 2,400. So 20,000 divided by 2,400 will give you 8.3. What's the unit? Meter per second, because we converted it to meters and that to seconds. Meter per second. Now, if you work with this, you're going to have kilometers per minute, and it sounds very, uncommon. I've not heard anything like that. But we answered the question as directed, meter per second. It's actually 8.33. So in this series, you're going to look at acceleration. To understand acceleration very well, you must have knowledge about velocity, which was treated in a previous series. Acceleration, which I represent with a small a, is the change in velocity with time. Velocity over time. Change in velocity with time. Final velocity minus initial velocity over time. So let's just start with this question. A car accelerates from 0 to 20 meters per second. Now, for this question, the initial is 0, final is 20. So 20, which is the final minus 0, over 5. 20 minus 0 gives us 20 over 5. So before we look at the final answer, which we know is going to be 4, let's break down how the units really work. Now, when we're treating velocity, we mentioned that velocity equals distance over time, meter over second. So we had meter per second, which is the standard unit for velocity, or kilometer per hour. But in the case of acceleration, we are mostly going to be working with meter per second. So let's stick to that. And now we are saying that acceleration equals velocity over time. So velocity is what? Meter per second over unit for time is what? Second. So it looks like meter per second per second. Meter per second per second. So per second here will be second squared. So we are going to have meter per second squared. So that's the unit for acceleration. Meter per second squared. A cyclist speeds from 5 meters per second to 50 meters per second in 4 seconds. What's the acceleration? Now, pause this video and try it by yourself. Alright, so acceleration equals final velocity minus initial velocity over time. Final velocity over here is 50 meters per second minus initial 5 over time. Take note it's in seconds, 4 seconds. 50 minus 5 is 10 over 4. 2.5. What's the unit? Meter per second squared. An object moving at 10 meters per second comes to a stop in 2 seconds. Find the deceleration. Now, deceleration means it's slowing down. Yes, the velocity is decreasing. Now, an object moving at 10 meters per second comes to a stop. The stop is 0. A stop is 0. So, acceleration equals velocity, that is the final velocity minus initial velocity over time. So, our final velocity is 0 minus initial is 10 over time, which is 2. So 0 minus 10 is negative 10 over 2, which gives us negative 5 meter per second squared. Now, assuming the question said find acceleration, the answer would have been negative 5 meters per second squared. But since it says deceleration, to tell you that it's actually going to stop. Final answer is 5 meters per second squared. Another word for deceleration is retardation. So when you see deceleration or retardation, you take the negative from your answer. Assuming the question still said find acceleration, the answer would have been negative 5 meters per second squared. So try this. The ball rolls down a hill with an acceleration of 2 meters per second squared. find its final velocity. So in today's series, we are going to look at calculation of weight. Let's calculate the weight of a 10 kilogram object on Earth. Take G equals 9.8 meters per second squared. Now, first thing, weight is a type of force. Weight is a force exerted by gravity on the Earth due to its mass, or it is a measure of the pull of gravity on an object. Now, there's gravity on every planet. Now, the gravity experienced on planet Earth has the acceleration to be 9.8 meters per second squared. So the formula for weight is mass times acceleration due to gravity. But you mostly see W equals mg. That's what you mostly see. So let's dive in straight into the question. So the weight is what we are supposed to find. The mass is 10 kilograms. So 10 multiplied by G, which is acceleration due to gravity, is 9.8. It's 9.8. So when you do your calculation right, you're going to have 98 Newton. Since weight is a type of force, force has a unit to be Newton. So that is it. An astronaut weighs 90 kilograms on Earth. What is his weight? What is his weight on the moon, where acceleration due to gravity is 1.62 meters per second squared? So on Earth, it's 9.8 meters per second squared, or you mostly see 10. But on the moon, it's 1.62 meters per second squared, which is 0.17 times gravity on Earth. So our weight is still equal to mg, acceleration due to gravity, and our g over here is 1.62. So our mass is 90 multiplied by 1.62. So working this out, we are going to have 90 times 1.62. We are going to have 145.8 Newton. 100 Newton weight is suspended from a spring scale. So 100 Newton here is the force. We've been given the force, 100 Newton. What is the mass? If G is 10 meters per second squared, so F equals mass times acceleration due to gravity. Our force is 100. Our mass is what we don't know, 10 times 10. So 100 equals 10 m over 10 over 10. 10 cancels 10. M equals, as the mass, 10. The unit for mass is kilograms, so 10 kilograms. So a force is a push or a pull on an object. And definitely that's what we are looking at in this series. A force is a push or a pull on an object. Now force has a formula to be mass times acceleration. Now, to just confirm something, acceleration due to gravity are not exactly the same, even though weight is a type of force. Now, it's in weight that you hear acceleration due to gravity. Now, the weight is the force that is exerted by gravity on an object. So when it comes to weight, or when you hear acceleration due to gravity, it has to do with gravity. When it comes to force, the acceleration you hear can be exerted by any object. For example, a car having a mass of 1,000 kilograms accelerating at 4 meters per second squared. Now the engines in the car, and the wheels of the car is what is helping the car to accelerate at this rate. So take note, force is mass times acceleration. Weight is mass times acceleration due to gravity. Whether gravity can be on the Earth, can be on the moon, or any other planet. So we have to find the force. So force equals your mass. Your mass is 1,000 kilograms. multiplied by the acceleration given to you in the question is 4. So force equals 4,000 Newton. And sometimes you are going to see this. Let me just break this formula down for you. You have kilogram for the mass, and then the unit for acceleration is meter per second squared. So sometimes instead of Newton, you see kilogram meter per second squared. It's also correct. So the next question, an object of mass 8 kilogram experiences a force of 80 Newton. What is its acceleration? So an object of mass 8 kilogram, then force 40 Newton. What's the acceleration? So your force equals mass times acceleration. Your force is 40 Newton. Then the mass, we don't know it. At our acceleration, the mass is 8 multiplied by acceleration, which you don't know. So in order to solve this, you have to divide both sides by 8. 8 cancels 8. 8 here 1, 8 here 5. So our acceleration is 5 meters per second squared. Always take note of your units. 50 kilogram box is pushed with a force of 250 Newton. Find its acceleration. So F equals MA. Our force is 250. What's the mass? 50 multiplied by A over 50 over 50. So 50 cancels 50. 50 here 1, 50 here 5. So A equals 5 meters per second squared. In this part of the series, you are going to look at velocity time graph. Now there are some basic things you are supposed to know. We already know that velocity is distance per unit time. So velocity time graph, how to draw the velocity time graph. So know that your velocity is here, your time is here. Now when we say constant velocity, it simply means that constant speed. So it means you have your diagram looking like this. So this is a representation of constant speed or constant velocity, where a straight line is parallel to the x-axis. Now, so constant speed. So throughout the questions, anytime you see constant speed, this is how our diagram is going to look like. The line is going to be parallel to the x-axis. So there's another term you would hear, uniform acceleration. Velocity here and time here. Uniform acceleration. Acceleration means what? Increase in speed. Should it be the last? Okay, we'll look at more. So anytime you have a decrease in speed, so you have your velocity here, your time here. This is how the diagram is going to look like. So this is also called uniform deceleration or retardation. So it moves this way and then goes that way. Your velocity is here, your time is here. Because it looks like initially the speed was just increasing regularly, then just switched. So this is non-uniform acceleration. So non-uniform deceleration would be something like this. So it comes this way and then goes that way. This might not be necessary when solving calculation questions, but might be necessary for explanation. So let's look at this question. A car moves with a constant velocity of 10 meters per second for 5 seconds. What is the acceleration of the car? Draw the velocity time graph for this motion. So the first demand is to find the acceleration. So in a previous series, I explained to you acceleration equals velocity over time. So your velocity in this question is 10 meters per second, 10 meters per second over your time, 5 seconds. So cancelling through, you are going to have 2 meters per second squared. Now take note that there is also what we call distance time graph. This we are dealing with is velocity time graph. So a distance time graph, you actually see distance here and time here. And that one will just be dealing with distance traveled to time. Follows the same approach. So for the sake of this lesson, So you have your velocity here, you have your time here. So this place is 0. That's for the spot. Now, a car moves with a constant velocity. Now, remember our diagrams. Constant velocity goes this way for 5 seconds. So, constant velocity of 10 meters per second. So, you can write 10 meters per second here. Then just make some short dashes. So, 5 seconds. Now, an extra question. You can be asked to find the distance traveled. Now, when you are asked to find the distance traveled, you can just find the area. Once you find the area, you know the distance traveled. So with this, you have a rectangle here. This is a rectangle. So finding the area of this rectangle, the distance from this spot to this spot is 10. And this side to this side is 5. So you're going to have what? 50 meters. 50 meters. How do I know? So velocity equals distance over time. Now, when you make distance the subject, you're going to have velocity times time. So your velocity here is 10 times your 5. That's 50. So let's move to the next question. A car starts from rest and accelerates uniformly at 2 meters per second squared for 5 seconds. Draw the velocity time graph for this motion, or the total distance traveled by the car. Now, you can pause the video and then try this question. The car starts from rest. So, information given is 2 meters per second squared. Then your time is 5 seconds. So, we move straight into action. Draw our diagram. You have velocity here, you have time here. Now, we don't know velocity. What we know is acceleration and then time. And from our previous series, we can find the velocity. So, acceleration. I've always said in my series that sometimes you are given a question, you can't find exactly or directly what you've been asked. Sometimes you have to use the previous knowledge you know. That's why I say science is cumulative. So, velocity on time. Acceleration is 2, so 2 equals velocity over time is 5 seconds. So we are going to have what? 10 meters per second. So we know our velocity to be 10 meters per second. So because we are drawing a velocity time graph, that's why you're supposed to know the velocity. So 10 meters per second. Alright. So we know our time to be 5 seconds. The car starts from rest and accelerates uniformly. Remember our diagrams. Start from rest. This is your 0 mark. So starting from rest and accelerating uniformly, this is how you expect the diagram to be. So I can start from rest and accelerate uniformly at 2 meters per second for 5 seconds. So this acceleration lasted for 5 seconds. So draw short dashes and indicate our 5 down here. Knowing that our velocity was 10 from the answer we had here. So we know that the velocity over here is 10. The next question is, what is the total distance traveled by the car? Now, the diagram that represents the question looks like a right angle triangle. And I said that to find the total distance traveled, find the area of the figure. Now, this figure here is a right angle triangle. And area of right angle triangle equals half times the base times the height. So half multiplied by the base. The base is 5 times the height. 10. 2 here 1, 2 here 5. So total distance traveled is 5 times 5, 25. Unit for distance is what? Meters. The car accelerates uniformly from 0 meters per second to 20 meters per second in 4 seconds. So let me just highlight the most important information. If it moves at a constant velocity for 6 seconds and decelerates to rest in 5 seconds, draw a velocity time graph, all the acceleration and total distance traveled by the car. There's so much information to imbibe here. So we are asked to first draw, but let's take it step by step. So the car moves, accelerates uniformly from rest. So remember our diagram. This is the rest, 0. So we indicate our 20 at the velocity side. So 20 meters per second for 4 seconds. 4 seconds. It then moves with a constant velocity for 6 seconds. I have to extend this. So we extend this. So for another 6 seconds. So if for another 6 seconds, it means that this time is going to be added. So a total of 10 seconds. And decelerate to rest in 5 seconds. So decelerates to rest in 5 seconds. Now a total of 15. So we are asked to draw. We are done drawing. What's the acceleration? Acceleration. Where did acceleration take place? Acceleration took place at this point. That's where acceleration took place. This is the point where acceleration takes place. And this is the point where deceleration takes place. So if acceleration took place here, pick up the information from this side and then find it. So acceleration equals velocity over time. Now, in this area, our velocity was what? We actually have two velocities. We have initial velocity and final velocity. Initial velocity is 0, final velocity is 20. So final velocity minus initial velocity over time. So our final velocity was 20 minus initial 0 over time. Time is 4. So 20 minus 0 is 20. 20 divided by 4 is given as what? 5 meters per second squared, because acceleration. The next thing we are supposed to find is the total distance traveled. Now in order to find the total distance traveled, as I mentioned, find the area of each of the figures. So this side we have right angle triangle. So half base times height. Let's call this place A. Let's call this B. Let's call this C. So for our A, half times base times height, half times our base is 4 times our height is what? 20. So 2 here 1, 2 here 10. 10 times 4 is 40. So we have 40 meters. That's for our A. Then for our B, this is a rectangle. So we are going to have length times breadth. So our length is 20. Then our breadth or width is 6. 20 times 6 is 120. 120 meters. That's for our B. Then for our C, we have a triangle as well. So half times the base. Base is 5 times the height 20. 2 here 1, 2 here 10. 10 times 5 is 50. So over here we have our 50 meters. So we have 40, we have 120, and we have 50. So we are going to add them. 40 plus 50 is 90. 90 plus 120 is 210. A plus B plus C is all 210 meters. That's our total distance traveled. So let's look at this kinetic energy. So let's look at this kinetic energy. Now what is kinetic energy? It's the energy possessed by a body with respect to its movement. So formula for kinetic energy is half times mass times velocity squared. Now the question says you should calculate the kinetic energy of a 2 kilogram object moving at 3 meters per second. So half multiplied by the mass, how heavy the object is, multiplied by the speed, the rate at which it is moving, a change in distance with time. So 3.5 squared. So half times 2 is 1. Then 3.5 squared. That's 12.25 joule. And take note that work and then energy, without energy you can't do work. So they are synonymous, the same units. 12.25 joule. So you can try this. Try this one. You can pause the video, try it, and then get back to the video. A 5 kilogram ball is moving at 0.5 meters per second. What is its kinetic energy? So kinetic energy equals half times mass times velocity squared. So half times the mass, which is what, 5, multiplied by the velocity, 0.5 squared. So 0.5 squared is 0.25. So you're going to have half times 5 times 0.25. Now we multiply everything. Half times 5 times 0.25. You're going to have 0.625 joule. So the next question is calculate the velocity of an object with a mass of 10 kilogram. So the mass is 10 kilogram and the kinetic energy of 200 joules. So your kinetic energy is half multiplied by your mass by your velocity squared. And in this question, we're giving kinetic energy to be 200. So 200 equals half multiplied by your mass times your velocity squared. So what can we do? 2 cancels this 5 times. So you have 200 equals 5 to the squared. So 200 divided by 5. Why? Because multiply both sides by 5. It's 40. So 40 equals v squared. How do you work this? You multiply both sides by exponent half. So you end up getting square root of 40 equals v. So square root of 40 will give us 6.33, 6.32. We're going to have velocity equals 6.325 meter per second. That's the unit for velocity. So in this series, we are going to look at potential energy. Now, potential energy is the energy possessed by a body with respect to its position. So potential energy formula is mass times acceleration due to gravity times height. So in this question, your mass is 2 kilograms. So 2 kilogram multiplied by acceleration due to gravity is 10 meters per second squared, and your height is 5 meters. 2 times 10 is 20. 20 times 5 is 100. 100 watts, 100 joule. A mass of 100 grams. 100 gram mass is lifted 3 meters above the ground. Calculate the potential energy. So the mass is 1000 grams. And the height is 3 meters. Now we're not given acceleration due to gravity. When you are not given, and the question requires that you can pick either 9.8 or 10. So I'll pick 10 in this question. So 10. So our potential energy equals mass, which is 1,000 grams. Now you are working with standard unit here. This is meters. This is supposed to be meter per second squared. That's for the acceleration due to gravity. So you have to convert the grams to kilogram. Now these are the basic standard units. We have meters for length. We have seconds for time. And then we have kilogram for mass. These are the ones you are most likely to find, or most likely to encounter in physics. There's Fahrenheit, there's Kelvin for temperature, there's ampere for current, then there's candela for luminous intensity. Then we have mole for amount of substance. So these are the standard units. So 1,000 grams equals 1 kilogram. So this is going to be 1. So for 1 kilogram, which is the mass, multiplied by the acceleration due to gravity, which is 10, multiplied by the height, which is 3. So you have what? 30 joules. An object has a potential energy of 100 joules. So the potential energy is 100 joules. And a mass of 4 kilograms. We have to calculate its height. Or no potential energy equals mass times acceleration due to gravity times height. So the potential energy is what? 100 joule equals the mass is 4 multiplied by acceleration due to gravity, which was given us to be 10 multiplied by the height. So 100 equals 40 times the height, which is h over 40. That goes side by 40 over 40. So we can get the height. So 40 cancels 40. 100 divided by 40. We have the height to be 2.5. We are going to use the standard unit, which is meters. Welcome to this series. In this series, we are going to look at moment. Now, moment is sometimes referred to as torque. T-O-R-Q-U-E. Now, what is torque? It is a measure of the tendency of a force to rotate an object about an axis or a pivot point. So, if you have, let's say, the hinge of a door, when you toss the door back and forth, there is a fixed point that rotates. Now, the measure of the tendency of the force to rotate the door is termed as torque. Now, torque depends on two things. It depends on the strength of the force and the distance. So this leads us to the formula for moment or torque. It is the force multiplied by distance. The force of 10 Newton is applied 2 meters from the pivot. Calculate the moment of the force. Now, before we look at the calculation, let's try to figure out the unit for torque. The unit for force is Newton multiplied by the unit for distance. Standard unit is meters. So Newton meter. So after doing your calculation, you have Newton meter by your figure or whatever you are calculating for. So the force over here is 10 Newton. So 10 multiplied by the distance 2 meters. So you are going to have 20. So 20 Newton meter. A spanner applies a force of 20 Newton at a distance of 0.5 meters from a bolt. What is the moment? As I've already explained, moment is the measure of the tendency of a force to rotate an object over here, and the object over here is the spanner trying to turn the bolt back and forth. So we state our formula for moment. Moment equals the force times your distance. The force here is 20 Newton. Your distance is 0.5 meters. So after doing your calculation very well, you are going to have 10 Newton Newton meter. The next question, a beam is balanced by 50 Newton force at 3 meters on one side. What force is required at 4 meters on the other side of the balance? Now think of a balance this way. We just use the simple rod to be our balance. So it's balanced by a force of 50 Newton on one side. Now if it's a balance, definitely you should have a turning point, which is a pivot. Now there's a force of 50 Newton on the left side balancing the beam, and there is this force as well balancing at the other side of the beam. So this force is what we don't know. Now there are some conditions that must be met for the beam to be balanced. This is a general rule for moment, solving questions in moment. So the sum of clockwise moment must be equal to the sum of anticlockwise moment. What does this mean? So let me just do this to represent the way a clock works. In this direction, we call it clockwise moment because this is the direction in which the the little arms on the clock moves. Now in this direction is the anticlockwise. Anticlockwise means the opposite direction of the arms on the clock. So on this beam, which one will we call anticlockwise, which one do we call anticlockwise? So on the right side, this is the clockwise. So clockwise moment equals a certain force we don't know multiplied by the distance, which is 4 meters. So the clockwise moment will give us 4F. Now anticlockwise moment, which I'll use ACW, 50 multiplied by 3. We have 150 Newton meter. Now, according to the condition, the sum of clockwise moments should be equal to sum of anticlockwise moments. So we are going to have the clockwise 4F equals anticlockwise moment 150. So divide both sides by 4. So 150 divided by 4. Our answer is 37.5 Newton. That is our answer. A seesaw is balanced with a 40 Newton weight at 2 meters on its side. So 40 Newton at 2 meters. So the seesaw is balanced with 40 Newton weight at 2 meters on one side and 50 Newton weight at the other side. Find the distance. So this distance, let's represent with N. Let me not use N because you already have N there. Let me use Y. So our clockwise moment, we have 50 multiplied by Y. I was thinking through it. This is how the clock moves. This is the anticlockwise moment. So anticlockwise moment, we have A, C, W. We have 40 multiplied by 2. Clockwise moment equals anticlockwise. So we are going to have 50Y equals 80. Divide both sides by 50 over 50 over 50. We are going to have Y equals 1.6 meters. So this weight is supposed to be 1.6 meters away from the center. So in this series, you are looking at pressure, and pressure is the force applied per unit area of an object. Let's consider these two surfaces. So you have this, you have this. So you put objects of the same mass on these two surfaces. So let's just assume that these objects are the same. Now, which of the surfaces is going to experience a greater force acting on it? A greater pressure. Pressure equals, take note of the formula, force over area. So this round or oval object, let's say, exerts a force of 20 Newton for each, 20 Newton for this side as well. And let's just assume that this object has an area of 5 meters squared, 5 meters squared, and this object has an area of 2 meters squared. So with the formula in mind, let's try to find the pressure for both. Pressure is force over area. So for A, the force is 20 Newton, the area is 5 meters squared. So we are going to have 5 here, 1, 5 here. So we have a pressure of 4 Pascal. 4 Pascal. And for this side as well, we have force of 20 Newton over an area of 2 meters squared. We are going to have 2 here, 1, 2 here, 10. So we are going to have 10 Pascal. So already I've mentioned the unit. The unit for pressure is Pascal, or let's figure it out from here. Unit for force is Newton, unit for area is meter squared. So it's going to be Newton per meter squared. Now let's look at the question. And realize something, that the greater the area, the lower the pressure. The smaller the area, the higher the pressure. From the example I just showed you, or from the demonstration I just did with you. So calculate the pressure exerted by a force of 100 Newton. So force equals 100 Newton acting on an area of 2 meters squared. Pressure equals force, which is 100 Newton, over the area, which is 2. So we are going to have 50 Pascal. The next question, kindly pause and try this. A box weighing 300 Newton has a base area of 0.2 meters squared. Find the pressure it exerts on the ground. So pressure equals force over area. So the force over here is 300 Newton, and the area is 0.2. So dividing, we are going to have 1500 Pascal, or we can say Newton per meter squared. Kindly pause and try this question. A piston has an area of 0.01 meters squared. A piston with an area of 0.01 meters squared exerts a pressure of 500 Pascal. Calculate the force applied. So pressure equals force over area. So the pressure is 500 Pascal equals the force, we don't know it, over 0.01. So your force will be 500 multiplied by 0.01. So 500 multiplied by 0.01, we get 5. We are finding force, so 5 Newton. Calculate the power output of a machine that does 100 joule of work in 10 seconds. So power, that's what we are looking at in this series. Our power is the rate at which work is done. So power equals work done over time taken. The unit for work is joule over unit for time is seconds. So the unit is joule per second, or watt, capital W-A-T-T, watt. So looking at this question, we have work to be 100 joule. 100 over the time is 10 seconds. So cancelling out, you are going to have 10 watts or 10 joule per second. Kindly pause the video and try this question. A 1000 watt motor runs for 60 seconds. How much work does it do? So power equals work done over time taken. So the power over here is 1000 watts. 1000 equals the work, we don't know it, over 60 seconds, which is the time. So the work equals 60 multiplied by 1000 equals 60,000 joule or 60,000 Newton meter. That's another unit for work. Now, in simpler terms, this is how you're going to write 60 kilojoule. Why kilojoule? Kilo means times 1000. Now, to conserve time and then not writing a lot of zeros, just say kilojoule. Now pause the video and try this last question. A man lifts a 20 kilogram object to a height of 2 meters in 5 seconds. Calculate the power. Power equals work done over time taken. Now, we're not giving the work, we're giving time, just time. That's what we're giving. So what you need to do when questions like this are given to you is, you don't start to find what you were told to find, because no matter what you do, you're not going to get it. Use the information you have to find something that is, closer to what you know. And from the information we have, we know time, but we don't know work. So it means you have to find it based on the information we are given or we've been given. So work equals force times distance. Now let's look through the question again. We have distance here, but we don't have a force. We can use this and that to find the force. So force equals mass multiplied by acceleration. Now the acceleration we have here is acceleration due to gravity. G equals 10 meters per second squared. So your mass is 20 kilogram multiplied by acceleration due to gravity. Why is acceleration due to gravity being used here? Acceleration due to gravity is being used here because the man lifts the object to a height. So anytime you are reading the question, you have to know what's actually going on. You are not just looking for numbers to input into formulas and then just compute. No. So 10. Our force is going to be 200 Newton. So the work equals 200 Newton multiplied by the distance, 2 meters. So the work is going to be 400 joules. Now that you have the work, you can find your power now. Work is 400 joules over the time, 5 seconds. Now working this out, you are going to have 80 watts. 5 here, 1, 5 here, 80. So a 50 watt motor does work for 20 seconds. How much energy does it use? So power, work done over time taken. So the power over here from the question, we know power is in watts, so the 50 here represents your power. 50 equals 50 watt motor does work for 20 seconds. How much energy does it use? So over the time, which is 20 seconds. So your work equals 50 times 20, which is going to be 5 times 2 is 10. So you add a number of zeros remaining. 1, 2. 1000 joule. In this series, we are going to look at velocity ratio. Now velocity ratio is the ratio of effort distance over distance moved by load, or load distance. So it is often represented as effort distance over load distance, and the unit for velocity ratio is velocity ratio has no unit. Effort distance in meters, load distance also in meters. They are going to cancel out, so velocity ratio has no unit. So let's begin right away with the question above. A machine moves a load 5 meters with an effort of 10 meters. The machine moves a load 5 meters with an effort 10 meters. So this is the effort distance. So equals 10 meters over 5 meters, which is the load distance. So 5 here 1, 5 here 2. So you're going to have about 2. That's your velocity ratio. The velocity ratio of a machine is 5, and the effort distance is 10 meters. Calculate the load distance. So we are saying velocity ratio equals effort distance over load distance. So the velocity ratio is 5 equals effort distance of 10 over load distance, which we don't know. So it's going to be load distance equals 10 on 5. So anytime you are doing change of subject and then you have your denominator to be whatever you are looking for, if you have an equal to sign, you can just exchange these two and it always works. So your load distance is 5 here 1, 5 here 2, 2 meters. Now take note, we are dealing with distance here, load distance, so it's 2 meters. The velocity ratio was 5, which had no unit. Now in the second part of this series, we are looking at mechanical advantage. Mechanical advantage is the ratio of load to effort. So in the question we have a machine lifts a load of 100 Newton using an effort of 20 Newton. Find its mechanical advantage. Now before we start, kindly take note that the load will be in Newton, effort will be in Newton. So mechanical advantage also has no units. So the load is 100 Newton and the effort is 20 Newton. So Newton cancels Newton. 20 here 1, 20 here 5. So mechanical advantage is 5. Kindly pause the video and then try this question. So if a machine has mechanical advantage of 3 and requires 50 Newton effort, calculate its load. So the mechanical advantage is 3 and the effort is 50 Newton. What is the load? We know that mechanical advantage equals load over effort. So the mechanical advantage is 3. The load is what we don't know, and the effort is 50. Now with this you can just cross multiply. So you are going to have load equals 3 times 50. So load equals 150 Newton. As we continue with this series, we are going to look at efficiency as well. Formulas for efficiency. You can have efficiency equals work output over work input multiplied by 100. We can also have mechanical advantage over velocity ratio times 100. So you are supposed to take note of all these. Now to the question. A machine has work input of 250 joule and work output of 200 joule. Calculate its efficiency. So we are going with the first formula. So the work output is 200 over the input, which is 250, multiplied by 100. Now always take note that your input will always be higher than your output. Why? Because some of the energy is wasted. That is why the efficiency of a machine can never be greater than 100%, or in terms of decimal can never be greater than 1. Alright, so to work this out, 10 cancels this, 25, 10 here, 10. So also 5 here, 5, 5 here, 2. So 2 times 200 is giving us 400. 400 divided by 5. So we are getting 80. So 80%. So efficiency is measured in percentage. Now pause this video and then try this. If the efficiency of a machine is 90%, calculate, so efficiency is 90%. Calculate the work input to reproduce 450 joule work output. So what input are you going to exert to get 450 joule? So you go by the formula, efficiency equals work output over work input times 100. So our efficiency is 90. 90 equals, the work output is 450. Let's represent work input with x, over x times 100. So to work it out, you have 90 equals 45,000 over x. So to make x a subject, let's exchange the positions. 45,000 over 90. So we are going to have 500 joules, which represents the work input. So in this series, you are going to look at electricity calculations that have to do with it. So we are going to start from the easiest and then build up in that order. Now there are some few things I'm supposed to bring across to you. So we have current, we have resistance, and we have potential difference. Is also sometimes mentioned as voltage. So current has a symbol of capital I, resistance capital R, potential difference of voltage has a symbol of capital V. Now current is measured with an ammeter, resistance is measured with an ohmmeter, and potential difference is measured with a voltmeter. Potential difference equals current times resistance, and we can also have power in there. Power equals current times potential difference. Current of 5 ampere, I equals 5 ampere close to a resistor of 2 ohms. Calculate the voltage or potential difference. V equals IR. So our current is 5 multiplied by our resistance, which is 2. We're going to have 10 volts. The unit for current is ampere. The unit for resistance is ohms. The unit for potential difference is volts. I can pause the video and then try this question. So a 12 volt battery is connected to a resistor. If the current is 3 ampere, find the resistance. So 12 volt battery. So we have 12 volts. It's connected to a resistor, and we're not given. If the current is 3 ampere, find the resistance. So V equals I R. You're supposed to find the resistance. So divide both sides by I over I. So I cancels I. So you're going to have resistance equals 12 volts over 3 ampere. 3 here 1, 3 here 4. So we're going to have 4 ohms. A 100-watt bulb operates on a 220 volt supply. Calculate the current flowing through it. So I give you another formula. Power equals current times voltage. Our power over here is 100 watts equals potential difference is 220 multiplied by the current. So you have to divide both sides by 220 over 220. So 100 divided by 220. So our current is going to be 0.454 ampere. If a resistor dissipates 50 watts of power when connected to a 10 volt supply, find the resistance. So power equals current times voltage. So the power here is 50 watts equals now looking at this formula, we will not be able to work it out, but we can bring the two formulas together and then do something. V equals IR and then P equals IV. Now what if we make current the subject? So over R over R. So R cancels R. So we have I equals V over R. So this simply means anywhere we see I, we can put V over R there. So P equals, now this is our I, which is our current. So V over R times V. So P equals V squared over R. So P equals V squared on R. So we are supposed to find resistance. Now, if you follow my series, I told you that anytime you want to make a denominator a subject and then you have a variable that is equal to, let's say, a fraction, just exchange the position. So R equals V squared on P. So we have V to be 10. So that's our voltage, 10 squared over the power, 50 watts. So 10 squared is 100 over 50. So 50 here 1, 50 here 2. So our answer is 2. And what's the unit for resistance? 2 ohms. That is it. Now pause the video and then try this. A current of 2 ampere. So I have a current to be 2 ampere flows through a 10 ohm resistor. Our resistance will be 10 ohms. For time 3 minutes. Calculate the energy dissipated. Now throughout you realize that we've not dealt with energy, but there's a way around it. That is why I told you in this series everything is connected, so you need to follow step by step, one video after the other. Now let me break it down. As I already mentioned, I said that if you are asked to find something that is not in the formulas, you need to use what you have to find something that is connected to what you have been asked to find. Now what is energy connected to? Remember, energy is connected to power. Power equals work done. Now the work here is synonymous to energy, so we can just say energy over time taken. So it means that if we don't have our power, there is no way we can find our energy. So we first need to work our way around to find the power. After we get the power, we already have the time, so we can find our energy or work. Okay, So we already mentioned that P equals V squared on R. And we also have P equals I V. Now, remember this formula. V equals I R. And what do we need here? We need to be able to connect our current and resistance. We can find our potential difference of the voltage. That was, you connect it to this formula. Our current is 2 ampere. So V equals 2 multiplied by our resistance is 10. So our potential difference of voltage is 20 volts. So right from here, we can fix it into this formula. So P equals V is 20 squared on R. What's our resistance? Our resistance is 10, and power is going to be 400 over 10. So our power is going to be what? 40 watts. Now if we have our 40 watts, we can work our way around. But take note, the time. Remember what I said about the time. We have to convert 3 minutes to seconds. Now, if 60 seconds make 1 minute, then how many seconds will give us 3 minutes? So 3 times 60. 3 times 60 is 180 seconds. So 180 seconds. So that's what we are going to work with. So we know our time to be 180 seconds and our power to be 40 watts. Time is 180 seconds. Our power is 40 watts. So we know power equals energy or work done over time taken. So 40 equals the energy over 180. So our energy dissipated is 40 times 180. 7,200. What's the unit for energy? Joules. A 9 volt battery is connected to 2 resistors, 3 ohms and 6 ohms in series. First, we are supposed to draw the circuit diagram. Find the total resistance and the current flowing through the circuit. So we should be able to draw. So a battery, a 9 volt battery. We have a battery here and our 2 resistors all connected in series. Then we have our 3 ohm resistor here and 6 ohm resistor also here. So we are first supposed to find the total resistance. Now, connection in series. RT equals, we are just supposed to add them. 3 ohms plus 6 ohms. We are going to get 9 ohms. So that's our total resistance. And we are supposed to find the current. V equals IR. Supposed to find the current flowing. So when you make I the subject, you're going to have I equals V over R. So we had 9 volts over resistance of also 9 ohms. So our current is going to be 1 ampere. I'll pause the video and then try this question. A 6 ohm resistor and 12 ohm resistor are connected in parallel to a 24 volts battery. Draw a circuit diagram for the setup. So I'll start with the resistors. Now this is also another symbol for resistor. Take note of that. This looks like a zigzag. Then 24 volts battery. So 6 ohm, 12 ohm. So 24 volts battery. So we are supposed to find the total resistance. Now, when it's connected in parallel, this is how you find the total resistance. 1 over RT. The RT represents total resistance over equals 1 over R1 plus 1 over R2. So R1 here is 6. So plus 1 over 12. So 1 over RT equals, so 1 over 6 plus 1 over 12. 1 over 4. Now, we are actually looking for RT, not 1 over RT. So whatever I do to the left hand side, do to the right hand side. So we can reciprocate both sides. So we are going to have RT equals 4. 4 what? 4 ohms. So we are supposed to find the current supplied. So V equals I R. We make I the subject, you are going to have V on R. So the total voltage here is 24 over resistance is 4. 24 divided by 4. We are going to get 6. So 6 ampere. The next question. A circuit consists of 10 volt battery, a 5 ohm resistor in series, and a parallel combination of a 10 ohm resistor and 20 ohm resistor. Draw a circuit diagram for the setup. So this is a question you need to take step by step. So a circuit consists of 10 volt battery and a 5 ohm resistor in series. So we are just going to take that. So there's your cell or battery and your resistor. In series, 5 ohms. Then you have resistors also in parallel. So the first one is 10 ohms, followed by the next one 20 ohms. We are supposed to calculate the total resistance. So we are going to work out the parallel first. 1 over RT equals 1 over 10 plus 1 over 20 to give us 3 over 20. So 1 over RT equals 3 over 20. Now we cross multiply. So we are going to have 3 RT equals 20. Divide both sides by 3 over 3 over 3. 20 divided by 3. Total resistance for the parallel is 6.67 ohms. Because we have another resistor connected in series, we are going to add 5 to it. So we get 11.67 ohms. So that's our total resistance, 11.67 ohms. Total resistance is 11.67 ohms. Then our potential difference of voltage is 10 volts. So V equals I R. So 10 equals, so our resistance is 11.67. Then it's the current you are looking for. So divide both sides by 11.67. 11.67 cancels 11.67. So 10 divided by 11.67, you are going to get 0.857 ampere.